Now, before we continue working with examples where it's going to involve with numbers, I want to cover some rules. Now, in the previous examples, I mentioned about where if a variable is by itself and a number is by itself, it always has an invisible exponent, which is the invisible 1. So x to the 1 power is simply just meaning that there's 1x. 6, when it's by itself, that means it has an invisible 1. So 6 to the 1 power means that there's just 1 6. Just like that. Now, another case is when it's being raised to the 0 power. So when it's x to the 0 power, it's simply going to equal to just 1. When it's 6 to the 0 power, it just means also 1. So anything being raised to the 0 power will simply equal to 1. So for example, if I had a to the 0 power, it will equal to 1. If I had 4 to the 0 power, it means 1. If I had m to the 0 power, 1. If I had 173 to the 0 power, it means 1. That's all it is. So anything being raised to the 0 power is simply equal to 1. When you have a variable or number by itself, it has that invisible exponent. So x to the 1 power, 1x. 6 to the 1 power, 1 6. That's all it is. For today's examples, we're going to be applying all laws of exponents, but in this particular example, we're actually going to have number bases. So instead of just working in variables like previously, now you're going to be working with numbers as your bases, or also known as coefficients. And pay very close attention, one of your variables has a negative exponent in the denominator. So pay close attention on how I work with our number bases and our negative exponents. So to start off, since I have an x on the top and bottom of the fraction in the numerator and denominator, same thing with the y's, I'm going to combine those first inside of parentheses before I work with the number exponent that's outside of parentheses. It's always helpful or make the work easier if you combine the inside, make the inside easier before you multiply your 3 to all the exponents. So my number bases, again, there's nothing on them except for that invisible 1. So when you see a number by itself, it's an invisible 1. There's nothing you can do, so they stay where they are. So 3 in the numerator and 2 in the denominator. Now my x, since it's a fraction, top minus bottom. So it's going to be 4. Now this is have to be very careful. So according to the law of exponent, it's going to be minus. But you see how on the denominator, it's already negative 5. So I'm going to write parenthesis, negative 5, close parenthesis. And I'm going to write another set of parentheses. Now I'm going to do the y's. So top minus bottom, so 7 minus, that's according to the law of exponents, and then my exponent in the denominator, which is just 2. And the whole thing being powered by 3. Now, let me go over between the x and the y. So, I had a set of parentheses on the negative 5, and now on a 2, because if you look closely at the original example, at the very beginning, x started off with negative 5 and y started off with positive 2 in the denominator. So according to the law of exponents, when it's a fraction, you see how both of them have a minus? The only difference is that I include a set of parentheses because it started off as negative 5. Over here for the 2, I did not, because it started off with a positive 2. Now, the reason I included a set of parentheses on the negative 5 is I want to emphasize that there's a minus and a negative. When there's a minus and a negative, when you simplify, everything will stay the same, so 3 to the 1 power, but it's going to be x 4 plus 5, just like that. Y is still going to stay the same, so 7 minus 2, just like that. over 2 to the 1 power. And then the whole thing powered by 3. Alright, so I'm going to write up here, the 3 stays the same. Now x, 4 plus 5 is going to be x to the 9 power. And then y, 7 minus 2, that's going to be y to the 5th power over 2 to the 1 power. The whole thing powered by 3. Alright, so when you have an exponent on the outside of parentheses and exponents inside, what we're going to do is we're going to distribute the 3 to all exponents. So I repeat, we're going to distribute the 3, this 3 right here, to all the exponents inside the parentheses. Now, what I have seen in the past is where students would distribute this 3 to the base, meaning that they would multiply, and then they would do the same thing to the 2. That's incorrect. You can never do that. So again, I repeat, I'm going to distribute this small 3 to each of the exponents that's inside the parentheses. So it's going to be 3, 1, and then I'm going to write this out to emphasize that I'm multiplying by 3. And then my x to the 9th. And then my y and I'm doing the same thing with the 2. 1 times 3. So all I'm doing was just multiplying the exponent. So it's going to become 3 to the 3rd power x, 9 times 3 is 27, and then y, 5 times 3 will be to the 15th power over 2 to the 3rd power. Alright, so when you're working with numbers, so 3 to the 3rd power, that basically means 3 times 3 times 3, x to the 27th, y to the 15th, and then on the bottom it's 2 to the power, so it's going to be 2 times 2 times 2. So when you simplify, when you multiply, it's going to become 27. That's 3 times 3 times 3. And then x to the 27th power. And then y to the 15th power over 2 times 2 times 2 would become 8. So that will be our final answer. And the reason it's our final answer is because if I were to compare between 27 and 8, I can't simplify these two numbers because there's nothing in common. So that means I am finished for sure. I have a single x, a single y with positive exponents, and I cannot simplify between 27 and 8. So that's all you can do for this example. So to review, be very careful when you're working with negative exponents, especially with number bases. Number bases, they always have that invisible exponent 1, unless it's already given. If you don't see a number base with an exponent, it's just invisible 1. And pay very close attention how I emphasize that I distribute or multiply the 3 from the outside to all my exponent. I did not multiply my 3 to the number bases, just the exponent. Be very careful. Alright, so we have a similar example where we have number bases and we also have a variable with a negative exponent. So let's simplify the inside first before working with this exponent outside of parentheses. So again, my number bases, my 3 and my 5, stay the same. Since the number is by itself, that means there's an invisible 1. So x, top minus bottom, so 2 minus 9, and then my y, 4. Now since it started off with negative 6 in the bottom, I'm going to write minus parenthesis, -6, close parenthesis, and then another set of parentheses on the exponent, over, and then it's just going to be my 5 on the bottom with the invisible 1 exponent. And then I still have the exponent outside the parenthesis. Alright, so let's simplify my x and y's. So the number basis will stay the same, so 3 to the 1 power. So x, 2 minus 9 would be -7. And then my y is become, since it's 4 minus -6, that means 4 plus 6. So 4 plus 6 will be y to the 10th power over 5 to the 1 power. The whole thing still have the exponent of 2. So again, we still have to simplify the inside because we want to make sure that the inside has positive exponent. So since x to the -7 is out on the top, to convert it to a positive, we're going to move the x to the opposite side, which is bottom, and then change it to +7. So it's going to be 3 to the 1 power, y to the 10th in the numerator, and then 5 to the 1 power, and x to the 7th. The whole thing powered by 2. Alright, now I'm going to write over here, since we were working with the 2 and everything is okay with positive exponents, so I'm going to multiply the 2 to all my exponent. So it's going to be 3, 1 times 2, and then my y, 10 times 2, over 5, 1 times 2, and then my x, 7 times 2. So what we're going to have here is it's going to be 3 squared y to the 20th power over 5 squared x to the 14th power. Now you can still simplify the numbers. I'm not going to write it out because it's square. Since it's positive 3 squared, that means 3 times 3, it would be 9. Y to the 20th power over 5 squared, meaning 5 times 5, so that's 25. X to the 14th power. So that's going to be my final answer because I ended with positive exponents. Now the one thing you have to be very careful is if you have negative coefficient, meaning instead of positive 3, that could have been a negative 3, or instead of positive 5, that could have been a negative 5. So you have to be very careful with negative basis in the event you're working with an exponent that's outside of parentheses or exponent that's inside where it's an odd number. So for example, if it was to the 3rd power, so had this been a -3 to the 3rd power means -3 times -3 times -3, which would equal to -27. Because negative times negative, that would become positive, times another negative will be a final negative. So be very careful when you're working with negative bases. This type of example, take your time, don't rush, especially when sign can be a factor, or when signs are involved, especially with negative exponents. Make sure that your final answer has positive exponents. Make sure that your coefficient is in the right proper place and right sign. So here we have positive, but in the event you do have a negative base with an odd exponent, there's a possibility where your final answer can be negative. So again, your final answer does not mean it's always positive, like positive 9 over 25. It could be a negative 9 over 25 if our basis has started off with negative. Now, again, this is our final answer because there's nothing in common between 9 and 25. You can't simplify. So that's all you can do.